Welcome to Physics Cartoon Camera. This channel for the rural students to enhance their physics subject. Yes, I received a lot of messages, emails from entire the rural students. I come across a few ideas what I can able to help to the students to enter the country. The background is channel. The most important is to make the students in easiest way to understand the physics concepts and applying the physics concepts in general life. So the physics cartoon camera is the basic theme is in our personal life what we are doing the work, each and every activity related to physics. I'm shooting a few incidents in my practical life. I'm explaining where the physics concept is. So while learning the hands-on experiments, while learning the different activities, yes, physics is one of a subject which is quite easier. Thank you viewers and students. Let's start with every day, daily 10 to 11 p.m. I'm teaching class 9th standard, 10th standard, 11th standard and 12th standard CBSE physics. So make join together to understand physics very well. Coming to class 9th standard, there is a chapter called as motion. Can we start? Yes. So now the basic question for us, what is motion? What we are learning in this chapter? There is a definitions: distance, displacement, speed, velocity, acceleration. Difference between distance and displacement, speed and velocity. Uniform motion, non-uniform motion. Graphical representation of motion. Equations of motion. Uniform circular motion. So what is motion? A very simple concept here. I am sitting in a chair. Yes, you are seeing me. Am I moving? No. Just I am moving from one point to another point. It looks like that, yes, I am moving. So now what is motion? There is something reference frame. My background, you can see any one of the point. From that point, my head is shifting little distance far away. So there is a reference point. Object is shifting from the reference point. Then we can say we are under motion. Yes. At the same time, you can see here a painter which is claiming a wall. How we know that he is claiming a wall? You can see the reference point here, there is a roof. He is climbing slowly, which is very near to roof. In this case, yes, he is under motion. Girl is walking in a park according to a tree or according to a small plant near to that. She is changing the position. Yes, she is moving. Car is running in a road. How we know that car is running in a road? There is a certain point of reference point. According to that point, car is changing the place. Then this is called as motion. Now how to define motion? If an object moves from one point to other point, according to a reference point is called as motion. Yes? Very easy we can able to understand. So let's proceed. Different kinds of motions in our personal life. Now, we always talk about motion of a body with respect to a reference point. Let's say from school to there is a 2 kilometers far away north side there is a railway station. We have specified the position of a school with respect to the railway station. So railway station is a reference point So we could choose other reference point according to our convenience. Hope you understood that. What is a reference point? Now, rest and motion. What is rest and what is motion? In this picture you can see that a person is sitting in a train. He is moving. Yes, of course he is moving. Now, next to the train platform is going backward direction. A small trees, platform and other passengers, we are seeing that yes, they are going backward direction. We are moving forward direction. At the same time, you can see very far distances, like a clouds or mountains or something, very far distances from the sitting place. You can see that the faraway objects which is lightly moving forward to us. Yes. So what's happening now? We can better understand. In the second picture you can see that there are the passengers, all are sitting, but train is moving. In this case, you can see next to next passengers. According to them, yes, they are sitting. You can compare these two. These two persons are sitting, they are at rest. Train is moving. But according to students who are all standing at the platform, according to them, both are moving. So the same person is at rest. At the same time, for other passengers, he is also at rest. So who are all standing at the platform? Yes, everyone is moving. Yes. Now the rest and the motion are relative terms. You can give any kind of example. Whenever you are going to school in the school bus, according to you, driver is at rest. According to outside people, driver is in moving. At the same time, we also looks like moving. So rest and motion are relative terms. We will continue further. You can see in a solar system, we are sitting on Earth. Planets are revolving around the Earth. Let's say our friend from the moon, he is seeing us. We are at rest now. We are listening the class. But according to our friend, we are moving. So we the persons, at the same time we are at rest and motion. Earth appear to be at rest with respect to us, but it is revolving around the sun at 30 kilometers per second. Is everything around us at rest and motion at the same time? Yes. The person sitting inside the bus is both at rest and motion in the same time. When his co-passengers is taken as a count, as a reference point, he is at rest. When trees outside the bus are taken as a reference point, he is in motion. A body can be at state of rest and in motion simultaneously at the same time with respect to two different bodies. So, motion is always relative. Have you ever experienced that while you are sitting in a bus, trees outside the bus appears to be in state of motion while the person next to you appears to be at rest? Have you ever experienced that the train in which you are sitting appears to move while it is at rest? You see the first question. We are sitting in a bus. Trees outside the bus appears to be at state of motion while the person next to you appears to be at rest. Generally we are saying, while we are traveling in a bus, next passenger is, yes, he is at rest. While we are moving, it looks like that trees are coming backward direction. So it looks like it is moving. Second observation. We are sitting in a train, we are at rest. While we are at rest, sometimes we will feel that we are moving. When it happens? If another train starts. Exactly we are at rest. But it looked like that we are moving. It happens only the next train if it is starts. Okay. Now, what is straight line motion? viewers, if you have any doubt, yes, you can ask me the question. Yeah, what is straight line motion? What is straight line motion? If an object travels in a straight line without changing any direction, without changing any direction, if an object moves, we can call it as object in a straight line motion. Fine. Now you can see this person is running in a straight line. He is not changing his direction, so he is in a straight line motion. Now let's say an example. A boy, he started at point O, that is at 0 kilometers. He went up to point A, that is 60 kilometers. And he reached to point B, and again he traveled and he reached to point C. Finally he is here. So this is a scale. On this scale there is a movement of a person. Okay. So now what is the distance he traveled? What is the distance he traveled? 0 to 60. 60 kilometers he traveled. Plus A to B. A to B on the scale, you can see 5, 10, 15, 20, 25 kilometers. 25 kilometers he has traveled. Plus B to C, again 5 plus 5, 10 kilometers he has traveled. So totally how much? 95 kilometers traveled by a boy. Okay. Now we will see the displacement later after clearing of distance concept. Now position and displacement. You can see in this picture, which is a starting to ending point over here. Very simple example. This is the school. Okay. And there is somewhere the student house it is. Now let's say house to school 5 kilometers. The student daily traveling in a bus 5 kilometers. Let's say he is traveling, this is the way. By school bus, he is traveling, this is the way. This path is 5 kilometers. He reached to the school. Okay. Now this path is 5 kilometers. Let's say one fine time this road was blocked. He unable to travel this is. Then what he can do? He can choose the next path. He can go any one of the other path. Okay. He choose like this. This will be again 5 kilometers? No. Again it will be change. Once path changes, obviously the distance will be change. Yes or no? Now this also blocked. Again he choose another path. Okay. This is again plus or minus 5 kilometers. So which path you chose, that is the distance. So how to define the distance now? The actual path traveled by an object is called as distance. Okay, the actual path traveled by an object called as distance. Now sometimes in our general life somebody will ask us, where is your house, where is the post office, where is the market, Just we will raise the hand, we will show. Yes sir, there you can go. So we can raise the hand, we can show the path. Why we are raising the hand? If you can go, that is the way, that is the shortest distance. Yes. So let's say from house to school, somebody asked, where is your house? The student said, there is a line. Yes. If you can travel this direction, but we can't travel. We need to choose the actual path traveled by an object, that is distance. But we can travel, this is the way. If you can, this is displacement. This we can call it as displacement. So what is displacement? The minimum distance traveled by an object. The minimum distance traveled by an object. Is called as displacement. Clear? Now we will see how much you understood in details. Let's say the student he started at point A, he came to point B, that is 5 let's say 3 kilometers, and point B to point C he stopped over here, that is 4 kilometers. Now calculate distance and displacement. Distance and displacement. So what is distance? Actual path traveled by an object. So this is the path object traveled, that is 3 kilometers plus 4 kilometers, which is 7 kilometers is the distance. So what is the displacement? A to C. This is the minimum path. Okay. So how to calculate this A to C? Now you can see in this diagram, it look like a right angle triangle. In this right angle triangle, you can apply the Pythagoras theorem. What Pythagoras theorem says is, AC square is equal to AB square plus BC square, that is equal to AB square in the sense of 3 whole square plus 4 whole square, which is 9 plus 16. AC square is equal to 25. AC is equal to square root 25 is equal to 5 kilometers. Generally square root 25 plus or minus 5 kilometers. But generally this is the positive displacement. We can say 5 kilometers is the displacement. Alright. Next kind of question. The student, let's say he joined at point A. He made one circle. He made a circle with R radius. Now what is his distance and displacement? Very simple question. The student, he started at point A. With R radius, he made one circle, he reached to the same point. So what about his distance? They didn't give any value to calculate. Very simple to understand. It's a circle. He traveled through circumference of a circle. Yes. So what is the circumference formula? 2 pi r. So 2 pi r is the distance. Now what is displacement? What is its displacement? Displacement will says that the minimum distance traveled by an object. Where he started, there itself he ended. Where he started, there itself he ended. There is no such distance. So the displacement value will be 0. Okay. Let's say one more example. A student, he started at point A and he reached to point B as a semicircle. Okay, let's say this is the distance, the radius from the semicircle is r. Now calculate distance and displacement. Now what is distance now? It's like a semicircle. Full circle circumference 2 pi r. Semicircle means 2 pi r by 2. That is pi r is the distance. Now what is displacement? What is displacement? A to B the distance. From center point to A and from here to B, r plus r. So the displacement value will be 2r. Very simple to understand what is distance and displacement. Any kind of question. Now we will see the different questions. We can see the difference between distance and displacement. What is distance will end? Actual path traveled by an object. From my house to my office, let's say that is 5 kilometers. 5 kilometers I am traveling with different directions, I am reaching to my place. So actual path traveled by an object, but my direction is keep on changing. So there is no proper direction. Yes, however the road turns, I am turning. That is the reason distance is scalar quantity. We can say distance we can able to measure. We can able to measure, but no direction. So distance is always positive. Distance is always positive. Coming to displacement. The minimum distance traveled by an object. We are showing the direction to someone. So if you can go, yes, you can go, that is the way. The minimum distance traveled by an object called as a displacement. We are showing the direction. So there is a direction at the same time magnitude, which means we can able to calculate. Hence, it is a vector quantity. Displacement is a vector quantity. Distance is a scalar quantity. Generally, students are asking what is scalar and vector quantities. It's a very new concept for them. Let us see that what is scalar and vector. What is scalar quantity and what is vector quantity? Let's say I asked a student, what is your age? He said something. Which direction? There is no direction. And I asked the same student, what's time now? He said, sir, 10:30. Which direction? There is no direction. So any physical parameter which is having no direction but magnitude, that is scalar. Let's say vector. What is vector? I asked the same student, what is your weight? Sir, I am 60 kg. Which direction? Downward direction. As you know that weight in the sense of gravitational pull on a mass. Yes, there is a gravitational pull on a body. Gravitation is downward direction. So that's the reason weight having that direction. 60 is a measurement magnitude. That is the reason weight is a vector quantity. So any physical parameter which is having magnitude and direction, that is vector quantity. Hope our students understood here. Next we can proceed. Let's see what you understood. I'm asking questions to the students. You can answer. An object travels 4 kilometers in east direction, then turns and travels 3 kilometers in south direction. Calculate its displacement. Very simple question. Let's say an object travels 4 kilometers east direction, then turns to 3 kilometers south direction. Calculate the displacement. Now what you can do this kind of questions, just geographically you draw that what is east, west, south, north. Okay. Yes. Let's say this is east, opposite direction west, north, south. Go for the question again. Object travels 4 kilometers east direction because that is the direction from the origin. Yes, this is 4 kilometers. And turns south direction 3 kilometers. South direction is downward direction. Okay. So point A to B, that is 4 kilometers. Point B to C, that is 3 kilometers. Now calculate the displacement to the set. So what is displacement? The minimum distance traveled by an object. So A to C. You can say this is. Apply Pythagoras theorem. Pythagoras theorem will say that AC square is equal to AB square plus BC square. So AB square in the sense of that is 4 whole square plus 3 whole square. Before we studied, that's what I'm cross checking how much the students understood. So that is 25 kilometers. AC square is equal to 25 kilometers. AC is equal to square root 25, which is 5 kilometers is the option. You can choose it. So let's see whether we are right or wrong. Yes, 5 kilometers is the right answer. Next. Second question. An object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. Repeating the question again. An object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. Yes or no? We studied now before. A student started at point A. With R radius, again he reached to the point A. You can remember there is a clue. Yes, there is a zero displacement. Now, how we can explain? If an object travels in a circular track, a racer completing a circular track, or pendulum of a clock after completion of each oscillation, moment of Earth around the sun in a year. Fine. Next, very important question. The students has to understand this question, then we can choose the right answer. The question here: a farmer moves along a boundary of a square field of side 10 meters in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Repeating the question again. A farmer moves along the boundary of a square field of side 10 meters in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Option A, 10 meters. Option B, 10 root 2 meters. Option C, 20 meters. Option D, 10 root 3 meters. So this kind of questions, most of the children are asking how to attempt the numericals in physics. Before that, the student has to read the question completely and he has to feel that he is doing the work. Then 50% of solution he will get it immediately. Next, he has to think what kind of formula I need to apply, Once you understand the question easily, then formula you can able to give very easily. You can see that you feel as a farmer. Understand the concept over here. I'll tell you how it is. A farmer, which means I'm moving along the boundary of a square field of a side 10 meters in 40 seconds. Okay, there is a square field of each side 10 meters. I'm traveling in 40 seconds. I have started at point A. I reach it to point A in 40 seconds. That's the first line. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? So time they have given 2 minutes 20 seconds. So 2 minutes 20 seconds, how many seconds? We need to calculate. 1 minute 60 seconds, 2 minutes 120 seconds, because 60 plus 60 120 seconds plus 20 seconds. So total seconds 140 seconds he is traveled. So what they're asking, what will be the magnitude of the farmer when at the end of 2 minutes 20 seconds? So I have traveled first one round in 40 seconds. Similar way keep on rounding. So the time came to 140 seconds. Where shall I stop? There is a question now. We need to understand where shall I stop. We will see. One round, first round I made in 40 seconds. Okay. What about second round? Next 40 seconds. Second round again next 40 seconds. How many seconds completed now? 80 seconds completed. Still 140 seconds pending. I need to walk. Now the third round, again 40 seconds. Okay. So 40 plus 40 plus 40. 120 seconds already done. Just 20 seconds left. So 120 seconds, 3 rounds I made it. Now one round came 40 seconds and 20 seconds where shall I stop? At here. Okay, at this point I have stopped. So half of distance I covered in 20 seconds, remaining half of I can cover in next 20 seconds. So that is the reason I have stopped over here. Let's say this is point B. Now what they're asking? Magnitude of displacement at the end of 2 minutes 20 seconds. First 3 rounds displacement value will be 0. One complete round displacement 0. So like the 3 rounds I made it. So 3 rounds also 0. The next last 20 seconds I stopped at point C. Clear? Now the displacement easily we can calculate from A to C. Yes. Now AC is the displacement. Again Pythagoras theorem we need to recollect. What is Pythagoras theorem? AC square is equal to AB square plus BC square. So AB square in the sense of 10 whole square plus BC square, again 10 whole square, which is 100 plus 100, 200. AC square is equal to. So AC is equal to square root of 200, which is square root of 2 into 100, which is 10 root 2. 10 root 2 meters is the right answer. Clear? We can see our answer is right or wrong. Option A 10 meters, option B 10 root 2 meters, option C 20 meters, option D 10 root 3 meters. Yes, we are right. We are right. 10 root 2 meters. Yes, there is a solution. Now, next question. Which of the following is true for displacement? First question, it cannot be 0. Second question, its magnitude is greater than the distance traveled by the object. Option A, both are false. Option B, first one is false, second one is true. Option C, both are true. Option D, first one is true, second one is false. So what's the right answer? Which of the following is true for displacement? It cannot be 0. What we studied? Displacement can be 0. So A option is false. Now you can choose A and B, both A option is false. Be careful. Second question, we can go ahead. Its magnitude is greater than the distance traveled by an object. Distance is greater or displacement is more value? Generally distance is more value. Displacement is not a more value. Again it's wrong. So both are false, which is right option is A. Let's check. Yes, exactly. Right option is A. Yes. Next. As you know, displacement can be 0. Displacement is always smaller than or equal to the distance of covered. Next. What is uniform motion? What is uniform motion? Uniform motion, you can see in this picture, the first at point O 0 meters, point A 4 meters, point B again next 4 meters, point C again next 4 meters. So each and every 4 meters of the distance we found out. A car travelled O to A 2 seconds, A to B 2 seconds, B to C again 2 seconds. So equal distances in equal intervals of time. Okay. An object travels equal distances in equal intervals of time. In equal intervals of time is called uniform motion. Students, no need to think how to define this uniform motion, no need to confuse. A car is traveling equal distances at the same time, equal intervals of time, that is uniform motion. Next, you can see the uniform motion graph. Distance time graph, if you mention equal distances in equal intervals of time, that is uniform motion, the graph will come from the origin to as a slope like this. Next, wow, what is this? I guess we played somewhere in Wonderla or any museums or parks. We noticed this. Children are very appreciating to travel like this. They'll feel so thrilled while going very fast and coming slowly. While going top, tram very slow. While coming down, very fast it comes. So they'll feel that yes, what is the speed now? Now easily define what is non-uniform motion. If an object travels unequal distances in unequal intervals of time, yes, very easy to identify. An object travels unequal intervals of time or unequal distances in unequal intervals of time. Either one unequal, yes, that is non-uniform. Unequal intervals of time. Is called non-uniform motion. Yes, the viewers, till now any doubts you can ask me. And in my profile, my email ID, you can ask any kind of doubts. So daily join from 10 to 11 p.m. as per the students' request. Yes, I'll deserve the students I'll join it daily 10 to 11 p.m. If you need notification, subscribe my channel and daily join it 10 to 11 p.m. And entire the rural country students, rural village students, I'm there to help you. Free of cost for you. There is no fees for you. You can learn, understand very clearly, practically. I'm there with you, all the students of country. Next, the graph of distance time graph. You can see there is a curved graph. Different distances in different intervals of time. The graph will come as a curved line. When a body covers equal distances in equal intervals of time, it's said to be uniform motion. Example, car driving at 40 km per hour, movement of earth around the sun, etc. When a body covers unequal distances in equal intervals of time, or equal distances, unequal intervals of time, or unequal distances in unequal intervals of time, is said to be non-uniform motion. Example, person jogging in a park. While we jogging, we don't know what is the speed. It will be increase or it will be decrease. So that is non-uniform motion. Wow! Who is going very fast? Very fantastic. Who is going very fast? Very funny, right? You can see that. Who is the winner? How to calculate the speed? Very easy concept to understand the speed. Join tomorrow. Yes, very interesting way we can learn it. What is speed? And we must be the speed in the education system. Very funny. Let's join tomorrow. Any questions? The country children, yes, you can ask me. Or you email me. Very fantastic. Yes, thank you. Thanks for joining today the live session, and every day 10 to 11 p.m. I'm S. Raman in front of you to develop our children. Thank you so much. Jai Hind.